Unit 4, Day 6, Graphing Quadratic Functions in Intercept Form. This is Mr. McGough up at R12. I'm going to be going over Day 6 with you. So first, intercept form. What they mean by that is the x-intercepts. This is often sometimes called the factored form. So you recall that your x-intercepts are where your graph crosses the x-axis. When it does so, y equals 0, or your function equals 0 at those 2 points. So they're called factors, zeros. Well, your factors give you your zeros. They're also called your solutions, your answers, your roots of your equation. So we're going to compare two equations, h of x and j of x, two functions. So h of x is 2 times x plus 3 and x minus 7. Those are our two factors. It's already factored out. J of x is not yet factored, but we can factor it. This would be x plus 3 times x minus 7. So when we take a look at that, first let's find what the roots are, or our zeros. On h of x, we can set x plus 3 equal to 0, and x would equal negative 3. We can set x minus 7 equal to 0, so x would equal 7. For j of x, our roots, or our zeros, would also be x equals negative 3, or x equals positive 7. So those are our zeros. To find our axis of symmetry, we'll try to find the place exactly between our two zeros, wherever that may be. It doesn't have to be the origin. This one that I showed as an example, it is. But here, what we're going to do is we're going to take the average of our two zeros. So 7 minus 3 divided by 2, that's 4 over 2. So our axis of symmetry is at 2. If we want to find our minimum value, we plug 2 back into our original equation. So 2 times 2 plus 3 times 2 minus 7 would be 2 times 5 times negative 5, which is negative 50. For j of x, because the two zeros are the same, the axis of symmetry is still x equals 2. Now I'll plug 2 into, or I'll substitute 2 into our original equation, x squared minus 4x minus 21. So I get 2 squared minus 4 times 2 minus 21, which is 4 minus 8 minus 21. 4 minus 8 is negative 4. Minus 21 is negative 25. Makes sense because h of x is 2 times the function being used for j of x. So h of x goes twice as low. So this is a parabola facing up, which you know because your a value is positive. So what's really going on here? Well, let's take a look at our potential right answers. The functions h of x and j of x have the same axis of symmetry. Well, that's true. X equals 2 for both. But the minimum value of h of x, negative 50, is less than the minimum value of j of x, negative 25. That's true. So A is definitely an answer. B, they have the axis of symmetry, but the minimum of h of x is greater. That's not true. C, the functions do not have the same axis of symmetry. Well, that's not true. They absolutely do. The functions do not have the axis of symmetry. Not true. So even though I found the right answer, looking just at A, I just took a look at all the rest of the answers, as you should too. So we're going to go ahead and move on to the next page. So the next page of our notes. X-intercepts. What are our x-intercepts? Well, they are the solutions when we set our function equal to 0. When I say that, I mean f of x equals 0 or y equals 0, however you like to say it. And then we solve. So our vertex. Well, first off, the axis of symmetry will give us our x value, which is the average of our two zeros, of our two x-intercepts, the x values. So that'll give us our x. And then we solve for y at x equals our number for our axis of symmetry. Just like we've been doing. Only now we're not using negative b over 2a because it's factored out. And the only way to get what our b and our a would be to multiply it all together. So that's a lot harder than just finding the average of two numbers. So here's some examples. First, we have f of x equals x minus 4 times x plus 2. The first thing we can see is what our zeros would be. X would be 4 or negative 2. The next thing we can find is our axis of symmetry. The average of 4 and negative 2, 4 minus 2, or 4 plus negative 2, divided by 2, gives us positive 1. So we'll plot our two zeros at 4 and negative 2, and we'll draw in our axis of symmetry at positive 1. Now we want to find our vertex, so we'll plug our x value back in. So f of x would equal 1 minus 4 times 1 plus 2. Negative 3 times positive 3 equals negative 9. So our vertex is the point 1, comma, negative 9. So let's plot that. Here's 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. When x equals 1 more than that, x equals 2. 2 minus 4 is negative 2. 2 plus 4 is positive 4. Negative 2 times positive 4 is negative 8. And it is symmetrical. If I increase x by 2 from 1, 3 minus 4 is negative 1, times 5, it's negative 5. 1, 2, 3, 4, 5. So we have enough points, we can go ahead and draw in our parabola. The min. This is an upward facing, or arrows up, parabola. So our min, f of x, is at our vertex, negative 9. Our domain, x is unrestricted, so we use all real numbers. You can write ARN, you can write this funky R, you can write all real numbers, but this is kind of the shorthand. It's R. The range goes from negative 9, inclusive, up to positive infinity. Where is it increasing? Well, let's highlight where it is increasing. It's increasing over the function from negative 9 to positive infinity. But it's not actually increasing at negative 9. That's where it also stops decreasing. So it's neither increasing nor decreasing at negative 9. So we have to look at our decreasing side of our function. It's from negative infinity to negative 9. Rounded parentheses. Where is it positive? It's positive when the value gives us something greater than 0. So it's from negative infinity to our first 0 at negative 2. It is not positive at negative 2. It's 0 at negative 2. So again, I use the round parentheses. It's also positive from positive 4 to positive infinity. So I use this U. It's a union of two sets. The set of all real numbers between negative infinity and negative 2, and the set of all real numbers between 4 and positive infinity, not inclusive. Where is it negative? Well, it's negative between the two zeros, where it goes below the x-axis. So it is negative from negative 2 to positive 4. What is the end behavior? As x approaches negative infinity on this left side, f of x approaches positive infinity. On the right side, as x approaches infinity, f of x approaches infinity. That is our end behavior. Number 2. Please note there is a negative sign out in front. So our vertex. Well, we can't get the vertex yet. First we have to find the zeros, which we can. 1 will make the first expression 0. 5 will make the second expression 0. Our axis of symmetry will be the average of those two. So we'll go ahead and plot those, 1 and 5, and we'll show our axis of symmetry at x equals 3. And then our vertex. We're going to put 3 in for x. So we have negative 3 minus 1 times 3 minus 5. 3 minus 1 is 2. 3 minus 5 is negative 2. So our vertex, negative times 2 is negative 2, times negative 2 is positive 4. Our vertex is 3, 4. We look back at A. 3, 4 is right here, by the way. And because A is negative, we know that it should be facing downward, or flipped, reflected over the x-axis. So we'll go ahead and draw in our parabola. Domain. X is unrestricted, so it's all real numbers. Range. Range goes from negative infinity up to positive 4. It is increasing from the left, from negative infinity up to x equals 3. It is decreasing from where x equals 3 to positive infinity. At 3, it is neither increasing nor decreasing. It is a max. It is positive from 1 to 4. 1 to 5. My other 0. It's not positive at either 1 or 5. It's 0 at 1 and 5. It is negative from negative infinity to 1 and from 5 to positive infinity. End behavior. As x approaches negative infinity, g of x approaches negative infinity. As x approaches infinity, g of x approaches negative infinity. Next page. More examples. F of x equals x squared plus 2x minus 3. Well, you can find your axis of symmetry by doing negative b over 2a. But since this is the chapter on the intercept form or the factored form, let's go ahead and factor our equation first. So this will be x plus 3 times x minus 1, which gives us our zeros at negative 3, comma, positive 1. Which means that our vertex is also the average of negative 3 plus 1 over 2, which is negative 1. Well, let's take a look at negative b. Negative b is negative 2 over 2a. 2 times 1 is 2. Negative 2 divided by 2, negative 1. So we're good with that. What is our vertex? Well, we take our value of x at our axis of symmetry and plug it in. Negative 1 plus 3 times negative 1 minus 1. So 2 times negative 2 is negative 4. So it is the point negative 1, comma, negative 4. We'll go ahead and draw in our parabola. What is our min or our max? Well, it's a min. And the value is negative 4. Our domain is unrestricted, all real numbers. Our range is from negative 4 up to positive infinity. It is increasing on the right, decreasing on the left. So, increasing from negative 1 to infinity. Decreasing from negative infinity to 1. At negative 1. At negative 1, it is neither increasing nor decreasing, it's switching. It is positive anywhere it's above the x-axis. So that's from negative infinity to negative 3, our first 0, and the union of sets from positive 1 to infinity. And it's negative between negative 3 and 1. The end behavior, as x approaches negative infinity from the right, f of x approaches infinity. From the left, as x approaches, sorry about that, little typo, as x approaches infinity, f of x also approaches infinity. And example number 4. Go ahead and pause the video, try this one on your own, and then restart it to see how we do. Okay, so we're going to factor g of x. The first thing we see is everything is negative and even. So we can factor out negative 2. That's our a, which means it'll be vertically stretched and flipped over the x-axis, or reflected over the x-axis. So when we take out a negative 2, we get x squared plus 4x plus 3. We can rewrite this. We can factor our quadratic to be negative 2 times x plus 1 times x plus 3. So we can see our zeros are at negative 1 and negative 3. The average of negative 1 and negative 3 is negative 2. The vertex will put in negative 2. So negative 2 times negative 2 plus 1 times negative 2 plus 3. Negative 2 plus 1 is negative 1. Negative 2 plus 3 is positive 1. So those two multiply together, make negative 1. We multiply that by negative 2, we get positive 2. So our vertex is negative 2, positive 2. We'll go ahead and plot that. And our zeros. So we plot our zeros at negative 3 and negative 1. So at negative 2, we'll plot positive 2 for y. And then that is our max, as we see. G of x equals 2. The domain. Well, let's go ahead and draw in our parabola. There's how that negative 2 works. It's steeper and downward. So our domain is all real numbers. Our range, well, our range will go from negative infinity up to positive 2. Where is it increasing? Well, it's increasing here on the left, and it's decreasing on the right. So it is increasing from negative infinity up to negative 2 for x. Oh, nope. I almost drew in the wrong bracket. Does not include negative 2 because at negative 2 it is neither increasing nor decreasing. That is the max. It is decreasing from negative 2 to positive infinity. Where is it positive? It's positive above the x-axis, so it is positive between the two zeros, non-inclusive. And it is negative from negative infinity to negative 3, and, or union, sets from negative 1 to positive infinity. And the end behavior, as x approaches negative infinity from the right, g of x approaches negative infinity, and as x approaches positive infinity from the left, g of x approaches negative infinity. So hopefully you got those all right when you stopped your video and practiced, and you'll have plenty more opportunity to practice these on your homework. Thank you.